Okay, guys. So during the previous session, we began chapter 6. And under chapter 6, we had four subsections that we didn't work on. We had four sections that we had to work on story. And we covered two of the four. Those two were the most important. I think as of the chapter, those two were the broadest and the most important. And we did take our time to cover all of these. And I think we're left with cloud computing and virtualization. So generally, chapter 4 had four subsections. Again, the first was Windows pre-installation. So it was all about the things that you get to do before to prepare your computer to receive the Windows operating system. And we also saw actually Windows installation, how you do install the Windows operating system on your computer, the various means of installation, and the issues or things that you're gonna get you have to get through, or things that you will face as you do install the operating system. Okay, so that being said, I would like to ask you guys what comes to your mind when you immediately come in contact with cloud, you hear the word cloud computing. When you directly hear the word cloud computing, what comes to your mind? Nabila, you can start typing your answer since your mic has a problem. And for Josh, I want to hear from you what you think cloud computing is.
I think cloud computing is like computing and not doing it like on a physical computer. It's computing like you perform computer tasks on the cloud. That's what I think. In the air.
In the air? Is it actually in the air?
No, not actually in the air.
So can you rephrase your answer?
In cloud, in computer, class.
Yes, like
Like
rephrase your, put it in another way.
that's gonna be cloud computing. This is computing. Uh, so this is cloud computing is 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 where computer tasks are performed in the cloud, in the digital space.
Okay, so if I understand, you're trying to say it is where you type documents in the cloud or somewhere.
Yes,
So
digitally, like
what kind of cloud is it? Is it Nimbus Cloud, Cumulo, or
no,
Nimbus
not
Cloud, or Stratus Cloud?
that's why I say digital cloud. Nimbus cloud can be digital cloud, like something like this. Electronic.
Digital Cloud. All right.
The cloud
So
can be
you wrote another concept. Can you say that again?
pardon, I never got the.
Can you say that again?
So,
Digital Cloud
should
can
I
be.
repeat the? See, easy digital. It can be like the internet. Internet is like,
Mr. Etienne.
Yes, sir. Good evening.
Very good evening. How are you doing today?
By the grace of God, I am doing well.
Okay, that's nice. You're welcome. Just before your intervention, we were talking about cloud computing. So we're trying to get the people's opinion on what cloud computing is all about. So as of our last session, our previous session, we began with chapter 3, chapter 6, sorry, wherein we saw a lot of things with respect to the Windows installation and pre-installation. So as of now, we're looking at the next two subtopics, which is cloud computing and virtualization. So we've decided to begin with cloud computing. So right, I was trying to ask, what is cloud computing? And one of our brothers here was saying it is cloud computing. It's like when you type documents in the cloud, a digital cloud. So I was wanting to know what he means by digital cloud, because when he said it, I thought, oh, cloud like the Nimbus cloud or the Stratus cloud. But then it did not really make sense that it could be the Nimbus or the Stratus cloud. Nevertheless, that's just to get your attention. Now that I have it, let's talk about this. Cloud computing is the provision of computing services and resources over the internet. And that's just it. That's the most basic definition we can get. Because if you try saying over the cloud again, you cannot define a word using the word. Because basically you might have an understanding of the word, but every other person must not have an understanding of that word. So when we say cloud computing is a provision, is a computing in the cloud, it's just basically paying more emphasis, just like repeating the concept that you just brought up. But then if we do break it down as providing of computing services and resources over the internet, I think it makes more sense. So overall, we can see that it is this other definition tries to give us more understanding of the concept without using the keywords of that definition within it. Nevertheless, we'll get a better understanding as we proceed. So some of the key terms we are going to learn as we proceed in this chapter is a concept like what is cloud computing in general, what is a public cloud, a private cloud, community cloud, and hybrid cloud. What category does it fall in, and what are the services that are provided within the cloud infrastructure? So the comprehensive or technical definition that we have of cloud computing here is a combination of software, data access, computation, and storage services provided to clients through the internet. But to the layman, the everyday person who has no IT background, we just say it is the provision of computing services over the internet, because software's data access, computation, and storage are all computing services and resources provided over the internet. But because you all are already IT technicians and IT engineers, you get to understand that we'll use more technical aspects to describe these things to you. So there are several types of cloud deployment models. So the availability of cloud, some particular set of people within the society have the provision of the cloud services to people in the society has brought about a situation whereby we have to break up the various types of cloud provisions. Various types of cloud provisioning. First and foremost, we have the public cloud deployment model, and it's a cloud that can be accessed by anyone, generally the whole public. So it is a cloud-based computing resource like applications, platforms, and even storage that are made available to the general public by a cloud service provider. Say, for instance, we have Google, who is a cloud service provider, and they provide us a lot of applications like Google Meet, Google Sheets, Google Docs, and Google Slides. There are a lot of them, even Gmail. These are all cloud applications. And most of all for cloud storage, we do have Google Drive. So we use these resources and even applications over the internet provided by by Google, which is in this case is a cloud provider. It is available to every person, as we all know, I think we all believe that anybody, irrespective of your race, your background, or your status, you can use Google Cloud without any problem. So the next type of cloud here is the private cloud. And it is a cloud that provides resources to a single organization. So as the term private entails, we get to understand that private clouds can be hosted internally, but because of the expense and expertise required to do so, they are typically hosted externally by a third party. So this means like Amazon, Azure, Amazon, Microsoft, or Google can provide a particular space in their cloud environment for a particular organization to own, which is going to be their private space, where only people that are concerned with that organization can actually access these resources. I don't know if I'm making sense, but I believe you should try to have a real idea of what the term private cloud says just from the word private. It belongs to a particular organization with access provided just to a few people. Community cloud, on the other hand, is a cloud that is designed to be shared by several organizations. Say like there is a merger between Brasseries, there is a merger between Google, Amazon, Microsoft, Twitter, and all these big tech companies. If they set up a server that can be accessed by employees from all these companies, that is a community server, that's a community cloud. Same as within a community, let's take Cameroon, for instance. Let's just assume that it's a locality and Douala is a locality and other towns, and can store their data or store applications over the internet, whereby everybody within this region can access these resources, so long as provided they are within these regions that we have named, that is going to be a community cloud. Nonetheless, there is a fourth type of cloud, cloud deployment model, which is hybrid cloud, and it generally entails cloud that means of cloud deployment model where that comprises of all the other models that we just named. It has the public, the private, and even the community cloud resources within it. So the goal behind a hybrid cloud is to expand the functionality of a given cloud service by integrating it with other cloud services. Some other key definitions that you're going to, some other terms, the definitions, some key terms that you're going to get inside this chapter, that is IaaS, PaaS, and SaaS. Let's start with IaaS, infrastructure as a service, or we instead let's take it from the list, from the topmost layer to the bottom one. We'll take software as a service. So a service that delivers software applications to the client over the internet or on a local area network is referred to as a SaaS, software as a service. I want you guys to give me one example each of a software as a service which is delivered over either a local network or over the internet. Both of you, those of you who are here, I need to type in your answers real quick as we continue. Examples of SaaS that you know. It's a service that delivers software applications to clients over the internet or a local area network. So generally, cloud computing is a pay-as-you-go model, whereby the resources that a person gets, he only pays for the things that or the items that he or she uses. Please, you guys should hurry and type in your answers real quick. We don't have much time. We need to cover the whole of this chapter. The next thing we have here is a platform as a service, which is simply a service that delivers everything that the developer needs to build an application essentially. So the deployment comes with cost and complexity of buying and managing the underlying hardware and software layers. So platform as a service, generally, as the term implies, provides a platform where a developer can access the tools that he or she needs to develop or build an application. Last but not the least, we have infrastructure as a service. Yes, it is a service that delivers infrastructure to the client, such as processing, storage, network, and virtual environments. The client deploys and runs softwares without purchasing servers, data center space, or network equipment. On further sessions, we are going to have a thorough discussion of this whole cloud computing thing. But because of our time limitation, we're just going to go ahead and explain this one is very necessary for us to understand within this chapter. So the next thing you have to know is in the cloud computing, we have computing tasks, CPU cycles, computing infrastructure, applications, defined business processes, and collaboration solutions. So those are the key terms that you get to understand. Now, we said that in cloud computing is the provision of resources and computing over the internet. So you can see here that this is a core, this is a calculations, this is data storage, and this is generally processing. So over network connections, all the different devices can access these services without having to physically have them. So if they say you're doing cloud computing, it's just the same as you're doing normal computing, but you're not having a physical computer that is processing all the data for you. This data is being processed over the internet and then sent or made available to you. So the various cloud types that we have are public, private, and hybrid. But community is not always very common for some reasons. That's why you see just 3 here, but always have in mind that there is a 4th one, which is community cloud. The public is accessible to anyone, the private just to specific people, organizations, or some paying clients. And in as much as the hybrid cloud combines all of these cloud deployment models. The next service there that we know of, we know that we find in the cloud is a software as a service, infrastructure as a service, and storage as a service, and even platform as a service. There are a lot more, but we are not going to see too much into details. What you need to know is you can even realize that one of them added again storage as a service. So we get software, infrastructure, and the platform as a service. But storage just comes up as another one where it can be absorbed into the infrastructure as a service or deploy cloud service, sorry. So some of the reasons why cloud computing is very advantageous, where the advantages of using cloud computing over any other type of computing are such that we can use multiple devices to access a single application. You can access these resources virtually from any location without any downtime, same as any other person from anywhere in the world could. You could you have access to resources and apps without duplication. There is no need to repetitively install these applications. You can single-handedly access these applications directly over the internet. And the provisioning or deprovisioning is simplified, which means getting these resources and then losing these resources is very easy. It is very, very easy to use. So some of the benefits here are said, like you self-service provisioning, which means you generally arrange your service with yourself. It is very easy to use through the use of APIs. I believe all of you here, most of you here actually are into the field of IT. And if you've known of APIs until date, just have it in mind that API stands for Application Programming Interface, and it's a means of providing the resource of a particular platform to an external or third-party organization, so much so that they can use these resources in their own system. Take, for instance, MTN Mobile Money provides a payment gateway where people can pay for services using their mobile phone. You, for instance, get yourself an e-commerce platform or a website that sells stuffs. If you need to receive payment on your website, you don't have to build a totally new payment gateway. You can simply utilize those that are already existing. In this case, you're going to utilize the services of MTN Mobile Money. But for you to be able to use the service of MTN Mobile Money on your platform, you need to get the MTN API or the MTN payment gateway installed on your own platform. In that case, you're using the resources of MTN through their API, in that case, an application programming interface. You're definitely going to learn more about that. From the mentoring aspect, we get to understand that it is a pay-as-you-go model. So you essentially only pay for the things that you use. You don't pay for anything more. The class is very silent. I want to know if you guys can hear me. Can you hear me? Okay, good. Good. So, yes, or infrastructure as a service is that type of, it's a hardware as a service that provides storage and computing resources, okay? The development as an environment or platform as a service is a solution stack that provides design, development, testing, and deployment environment for the users. Whereas SaaS is an implementation of applications over the internet or used over the network, such as business applications, and it is simple and multi-tenancy. It is simple and it has multi-tenancy, which means it is not difficult to implement and a lot of people can use at the same time. So conclusively, we have talked about infrastructure as a service, platform as a service, and software as a service. You're charged with the task of going to get a better understanding of what cloud computing is all about, and alongside all the services that are provided within this environment. So we're going to be looking at the next or last sub-module inside this chapter, which is virtualization. Just before we proceed with virtualization, I would like to get questions from you. Questions or things that you have not understood. We would like to talk about that now. So open to your questions. Do you guys have any questions? No questions. Let me ask my own question. What is an example of a SaaS? Give me an immediate example of a SaaS. You can type it. George. George. Is George in this class? That is a Google Workspace, as Nabila is just putting in the chat section. It's a platform as a service. It provides all the resources that a developer needs to use to interact with a particular set of information. So you're saying that the practice of using a network of internet servers to store, manage, and process data. Yeah, that's very correct. I didn't see this definition. The definition of cloud computing was very correct. It is not wrong. In fact, all the definitions are correct. It is just that you need some more spice in some particular places to make it more professional. Nevertheless, an example of SaaS here is what we are currently using to. Which platform are we all using right now to interact? We are using Zoom, of course. Yes, it is Zoom that we are using. But why exactly did you guys not be able to figure, why did you not figure this thing earlier? We are using an application where the resource of this application, though we have an interface or a portal installed on our device, the Zoom servers, the actual part that does all the processing, they are not here physically. You cannot use these resources here without the internet. Reason being that all the resources of Zoom are in a server. So Zoom is a SaaS. Another example of a SaaS is Google Meet, and essentially WhatsApp, all the other ones that you use. Most of them are SaaS. They rely on internet connection to operate. So those are some examples. I would like to classify Google Workspace as Cynthia said earlier, within the category of platform as a service, because you have a lot of tools, a lot of SaaS within that environment. Okay. So right now we are moving on to virtualization. What do you think virtualization is all about, people? What do you think virtualization is all about? What do you guys think virtualization is all about? Nobody saying anything? Okay. I'll still ask the same question at the end of the class, hoping that you guys have virtualization is replacing.
Let me try.
Wow. Go ahead.
So let me try.
Yes, go ahead.
Virtualization is a technology that you can use to create visual representations, like the creation of visual representative on paper. Is what you are seeing now on the show. That's what I think visualization.
Your network is very choppy. Your network is very choppy. I didn't get any of what you said. Just type it in the second comment. Take your time and type in the chat section.
Okay.
Yeah. So the skill that you guys are going to learn within this section is how to use VirtualBox, VMware Player, Hyper-V or hypervisor, how to create virtual machines, and how to create virtual hard disk. But before that, we get to know what all of these are. You cannot be creating stuff so you don't even know what they are in the first place. So let's look at the key terms that we're going to be talking about here. Hypervisor, virtual machine, virtual hard disk. In general, then we then see what a virtual switch, a vSwitch is, and what a vRouter is. If you know what a switch is, if you know what a router is, then definitely you already know what a vSwitch or a vRouter is. Nonetheless, the hypervisor is let me just keep this. And I want to hear from you people. What do you think a hypervisor is? So type also in the comment section. Type in the comment section what you think a hypervisor is, what you think a virtual machine is, and what you think a hard disk is, because most of you, I believe, you cannot speak. So just type it in as well. Type it in. We still have a couple of minutes. It's enough for us to finish the chapter. We have just 18 more slides and we'll be done. From the look of things and the general presence, we are going to start all over again on this. We're going to start this whole chapter all over. And not exactly the whole chapter, but to 6.3 and 6.4, because it is something that I don't want a lot of you to miss out on. So it's just quite unfortunate that few people were present today for some reasons. For some reasons, most of you are not present. But we're going to see how we can solve that. We are going to see how we can implement something to solve that situation. Okay. So yeah, is used to create virtual representation of services. What is used to create virtual representation of servers?
It's visualization.
Yes. Go ahead, please.
So my internet is not virtualized.
Okay, virtualization. Abila, do you have anything to add? Okay, so basically virtualization is yeah, she doesn't have anything to add. So virtualization is that technology that one can implement to create a type of non-physical version of computing resources within a particular computer, which we refer to as the host computer. I don't know if that makes sense, guys. So you actually take a physical computer, you split it up inside, and then create several other computers inside so as to maximize usage of that computer, because a lot of our computers don't even operate their maximum. So a lot of resources are being wasted. If we tend to need more computers, we'll have to buy other physical computers, whereas all the single computers that are standing are being underutilized. In order to maximize the utilization of these computers, virtualization is now implemented so as to create how will I say, a software version of the computer storage, of the computer's hardware, and all the computer's interface in general. Okay, so you can basically virtualize everything, every resource within a computer, and that's what virtualization is. So as of a hypervisor, I don't think you guys can know what a hypervisor is, but a hypervisor actually comes in two types, and it is a thin layer of software that resides between the virtual operating system and the computer hardware. When we talk now about virtualization in the case of operating systems, it is the virtual representation of the computer operating system within another operating system, whereby the main operating system is referred to as the host, and then the operating system which is installed within the operating system is called the guest operating system. I think that we also have to guide you through how to install and utilize VirtualBox. We should do that probably after our class of Friday. All of you are going to install VMbox, VMware, or VirtualBox, whichever you like, and actually install an operating system inside. It's going to first help you to assimilate the whole chapter 6, and then next is going to permit you guys to as well, it's going to permit you as well to like have a grasping of an understanding of what the whole operating system installation concept is all about. So yeah, let's take these definitions and just speed it up. You're going to get back to these stuffs. So a hypervisor is a thin layer of software that resides between the virtual operating system and the hardware. So a hypervisor allows virtual machines to interact with the hardware without going through the host operating system. Well, this is just for a particular type of hypervisor, which we refer to as the bare metal hypervisor or the type 1 hypervisor. So there are two types of hypervisors actually. One that permits the virtual operating system to interact directly with the hardware, and another one that permits the virtual operating system to interact with the hardware through the main or the host operating system. I don't know if that makes sense. So yeah, one that goes directly to and communicates with the hardware is a bare metal hypervisor. Bare metal as in this word, bare metal. Bare metal hypervisor, it interacts directly with the hardware. And there is another type of hypervisor, which is a type 2 or hypervisor that interacts with the operating system. First, the main one before going to the hardware. Because I believe you understand that an operating system is a software that provides permits applications to access the hardware, or that controls a set of instructions or rules that tell the computer hardware how to operate. So an operating system being also a software is a virtual operating system, sorry, being also operating the same as normal operating system, has to communicate with the hardware as well. When it communicates directly with the hardware, it is through a bare metal hypervisor. But when the virtual operating system has to go through the host operating system first, the hypervisor that is implemented there, once again, is a type 2 hypervisor. You all can do more research on that. Next, a virtual machine is a software implementation of a computer that functions like a physical computer, including all the application execution, except it is within another computer. That is what a virtual machine is. A virtual hard disk is a file which is created inside the host operating system while you're creating a virtual machine that simulates an actual hard disk. A virtual hard disk is the extension for that file is VDI, and when you will be installing the virtual machine, you're going to see that there is a file that will be created in a particular folder that will have the extension VDI. So that would be your virtual hard disk file. So the same way you have an SSD, and an HDD physically, you're going to have a virtual format of it created as a folder whereby you will see which will play the role, which is created as a file, sorry, that will play the role of a physical hard disk. That being said, I want you guys, what a virtual switch. Do you know what a switch is? Do any of you know what a switch is? A switch. Okay, seems like Josh has a problem with his network. Okay, seems like you don't really have much to say about it. A connective media which allows distribution of internet. When you say that, it's like if there's no internet, it's not going to work. It simply routes data within a network, within the various devices that are connected in a network. If you say so, I think it will be much better. A lot of people are requesting right now to join the class, but I think we should just conclude and then give them the chance to give them that opportunity to get back with us during the next session. For Friday, we're going to review the whole thing again. So it's an opportunity for you to go over it a second time. Good. So that being said, a vSwitch is software that facilitates communication between virtual machines by checking data packets before moving them to a destination. A virtual switch may be software installed on the virtual machine, or it may be part of the server firmware. I want you people to write this down. You have an assignment, both of you that are in this class. Your assignment is to get a proper definition or a tailored definition, your definition of a switch, a router, their functions, and their functions. Yeah, exactly. So the proper definition, the advantages of using them, and their functions. So I'm expecting that from both of you Friday, that's after tomorrow. Same time, before the class. I need to see them before the class. Please don't let me remind you. I'm begging you, please. Don't let me remind you.
So please can you write down the question in the comments?
It's going to disappear.
Yeah, just
Okay, I'm doing that. Okay. So that's in the comment section. Okay, so we continue from here. I actually think, on the look of things, since we are going to be covering the whole of this all again, all over and over again. Do we finish the whole things? We have information. What do you guys think? Nabila, this is a perfect opportunity. This is a perfect opportunity for you to troubleshoot your computer and solve your mic problem. Try to solve the problem that you're having with communicating. It is important for your mic to be okay. That's why we give you time in the beginning of the session to prepare yourself and the resources so that you don't have this kind of complication. Go take time to understand what the problem is and find this. I believe it is. So the general computing model, the thing somewhere or one laptop that has an operating system which communicates with the CPU, the storage, and the memory, and you have applications that are installed on top of that operating system. But then when you do this like that, all those applications, they can only utilize about 10%, 9%, or maximum 15% of the whole computer space. So you now see that a lot of the computer's processing power is being idle, it's idle and it is not utilized. But then what if instead of having a single operating system on a particular computer system, you instead get yourself a hypervisor installed in the place where you've had your operating system, right? Then the operating system now is installed on top of that hypervisor, but the hypervisor is the one managing the CPU, the storage, and the memory. And then several operating systems, like 3 of them, are now actually installed on top of the hypervisor. This now provides you with a means to utilize all of the resources that you see here, which was idle initially, because here this is just one operating system. If you put 3 or 4 more operating systems, the way you see on this representation, definitely you're going to get a more utilization of your whole resource. Now, this is for type 1 hypervisor. This is a type 2 hypervisor. I think I talked to you guys about the bare metal one, the one that directly communicates with the computer hardware. But we also talked about the type 2, which is a hypervisor that is installed on the host operating system. Then you can now have several virtual machines or several operating systems installed on this hypervisor. So some advantages of using the virtualization is that it is very agile. It is agile, possible for you to implement several computers on a single one and then actually create more environment for you to work. It is flexible, so you can easily scale down or scale up the computing resources. There is increased performance, given that instead of one computer, instead of one server, you might have 3 more now. So definitely you're 3 times more effective or more performant. The scalability of it actually makes you understand that you could easily set up several operating systems or several computers within a single computer unit. And generally, the most important is cost saving. So from the virtual desktop infrastructure or VDI, the VDI is actually an infrastructure for your computer that is set up in the cloud, where a desktop is being virtualized, right? So virtual desktop infrastructure is where the desktop are being virtualized on top of a single computer system, which acts as the host. Through a connection broker, the end user can access any of these desktops, but you don't need to actually have these desktops physically placed somewhere, but they can all be virtualized within a single host system. So VDI implementation can be on-premise or in the cloud. It is simply providing computer interfaces or computing resources for users to try and connect and use the various computer interfaces on a single server. This means that you can get one server and then you implement several operating systems inside. where all your workers can then connect and then use those operating systems all at the same time without you having to get them single or individual computers, all of them for all of them, or with the respective processing resources. So you could do an on-prem VDI or a cloud VDI. So the some features or the features of the on-prem VDI is that all the resources, the hardware and software are both bought and owned by the company, while in the cloud, the hardware and software is bought and owned by a third-party company. Your company is just renting access to those resources. So there's another type of virtualization which is called container virtualization. It is contrasted to VM, to the regular virtual machine of a VM, to the regular virtualization, in that it rather englobes all the operating systems that are going to communicate with the operating system, and then gives them like they identify themselves as a single unit. So they don't come as individual operating systems passing out to get through the operating system, passing the kernel to go through the operating system, but there's instead a container that contains all of them, and it actually behaves as if it was one computer, but those resources are now distributed to all these computers individually. So containers are more lightweight, they are less portable as compared to virtual machines, they are smaller, it is very easy to start up, and it is modular. Whereas virtual machines, they are heavy, they are more portable, they are larger, and it takes a longer time to boot up or power on. So in order to secure a virtual environment, you have to secure the host platform first, develop proper managing procedures, and secure your virtual networks, okay? Then document virtual networks and virtual machines. So the features that you've implemented and security measures, you have to provide documentation or written explanation for all of these. So summarily, in this section, we've talked about virtualization, the various types of hypervisors, including type 1 and type 2. We've also talked about virtual desktop or VDIs, the container virtualization, as well as security measures, how you do secure your virtual environment. So that being said, we've come to the end of this session, and I'm really open to getting questions from you before we call this a day. Any questions? Any questions, guys? I'll take that for there's no question, so I'm just going to stop recording right now. And yeah. Do you have a question?
No, sir.
Okay. Booting does not need data. When you say data, what do you mean? Like access to the internet, or how? Booting is a process of turning on an operating system. From the time the operating system turns on, when you press the button, the time it turns on. That is the process that is referred to as booting. Okay, it is not like booting needs internet connection and stuff. Because your normal machine boots up all the time. Your computer boots up every time you turn it on. That process is not called turning on. It's called booting up your operating system. I believe you've understood. Is that understood, Nabila? Okay, so we're gonna stop recording now. Do you have any further questions before we stop the recording? Do you have any more questions? So yeah, we stop the recording here. The recording will be shared in the group, but nevertheless, remember, you guys have an assignment. Get it from the chat before we exit. And then don't tell me you forgot. Get it from the chat before we exit. And we'll be seeing that before the session of Friday, and we'll be covering a lot of things on that Friday in as well as so included would be this particular 2 modules that we just keep. We're going to get a general review of chapter 6 before going to actually move into chapter 7. So that being said, you guys have a great day.